Alright, now let's learn about thin films. Okay, thin films. For thin films, the order also start from 0, yeah? 0, 1, 2, 3, yeah? Okay, now first thing in thin films, you have to know what is phase change. This is very important concept in thin films. What is mean by phase change? Or sometimes we say phase inversion. Invert, yeah? Because invert means become opposite. So phase change or phase inversion. Yeah, actually from the terms inversion itself seems clearer. Inversion basically it means like that. The wave actually it going upwards. Yeah, initially it's going upwards, but once invert it become the opposite. Invert. Invert. This is called inversion. Phase inversion. Initially the wave is going up, but after invert become going down. This invert for how much? This one actually invert for this one invert or we can say phase change for pi radian. Pi radian phase change, invert, invert, or where you can say invert 180 degree. Invert, become opposite. Actually, this 180 degree pi radian is almost equal to half lambda. Yeah, because we know 1 lambda is equivalent to 1 lambda is equivalent to 2 pi radian or 360 degree. Yeah, 1 lambda is 2 pi radian or 360 degree. So half lambda is pi radian. Okay, so if invert from going upside down, invert upside down, that's pi radian, okay, of half lambda, or we call it phase change for pi radian or half lambda. Okay, now how do the phase change happen? This is the most important thing. When it happen? When? I already give you the key. It only happen when reflection from lower to higher refractive index. It only happen during reflection. We have two. We have reflection and refraction. Refraction means the light is transmitted. This one for refraction is transmitted. It is the transmitted light. Transmitted light. For reflection is reflected light lah. But this phase change never happen in reflection. Phase change never happen in the transmitted light. Never happen in the transmitted light. It only happen during reflection, the reflected light. That means what I can say is like that. Transmitted light. The light. This is the another medium. Maybe maybe put some blue color. Okay, so this is another medium. Okay, phase change happen when, because the light, the incident light, part of it is 50%. I can say 50% of light reflected. Normally 50%. This is the incident light. The incident light. 50% of light reflected light. 50% of light actually transmitted light. Transmitted means the refraction one lah. The refraction one. Okay. This is from medium 1 go to medium 2. So these are two medium. Maybe from air, going to the glass. From air, the refractive index is equal to the air. Again, for the air, the refractive index equal to 1. The glass refractive index equal to 1.5. Different refractive index. So when is the phase change happen? Phase change never happen. Phase change never happen here. Phase change only happen here. That means have pi radian phase change. You have pi radian phase change. This one no phase change, we put as 0 radian. Okay, no phase change. So phase change only happen for the reflected light. What I can say, only happen during reflection, and it must happen during the light reflected from lower to higher refractive index. It means the light must go from let's say from air going to glass. From air going to glass, reflection, and then got the phase change happen, phase inversion happen, or pi radian or half lambda. Okay, it never happen. It must happen during lower to higher. It never happens from higher to lower. That means, let's say I have this one. Okay, no. Let's say I travel from here. I travel from I travel from the reflected light. Yeah, this one reflected light. Okay, the incident light travel from glass. Yeah, from glass go to air. This is the air. From glass go to air. Reflection. We have a reflection and the transmitted refraction here. Refraction, the transmitted light. Okay, no phase change happen for either of these. No phase change. Yeah, 0 radian, 0 radian. Okay, phase change only happen when it never happen. It never happened during refraction. Never happened during refraction. That means from air, refraction never happened here. Refraction never happened, and it only happened during reflection. And also the condition is reflection from lower to higher refractive index. I mean reflected from a higher refractive index. That means the light is traveling from air to glass. Reflection. Got pi radian phase change. Here got phase change. But if the reflection happens from higher to lower refractive index, like this one, the light going from higher from glass to air, going from higher to lower refractive index, reflection, no phase change also. So the phase change might only happen for this part. Yeah, for this part, I can say for this part only. What I can say is for this one only. Phase change only happen in this condition. Reflection must be reflection. Reflected light must be reflected light, and then must from air to glass. Cannot be glass to air. Must from air to glass. That means from soft medium going to hard medium. Soft medium going to hard medium. Reflection got phase change, pi radian. So all the other condition no phase change. Understand? So okay, we will look about that later on. Phase change only happen during reflection from lower to higher refractive index. Now let's look at this one. What is actually phase change? Phase change, like you see here, this one is from what I say, N1 is less than N2. That means I can say N1, this N1 equal to 1. This N2 is bigger, 1.5 from air to glass. Okay, this one got pi radian phase change. Got pi radian phase change. But this one, N1 is bigger than N2. That means N1 is 1.5 from glass to air. N2 is 1. That means air. So this one no phase change. Reflection, this one no phase change. No phase change. Got phase change, we say got pi radian phase change. Or we can say got half lambda phase change. Half lambda phase change. Okay, so what is actually phase change? Like you can see, phase change means like this one. Initially go up, it invert, go down. If no phase change means it never change. 0 radian never change. It means the incident wave is going up, the reflected wave also going up. Never change any. It's still maintain. It's still maintain going up. Phase change become going down. So maybe I can show you one videos on this, to see clearer these videos. Do you see that? Maybe wait. You can before we look at this video, I want you to look at the notes here again. Yeah, phase change we can imagine like a rope. Actually, wave also can travel in a rope. So you see this incident wave. This incident wave comes here. It makes if here the rope is fixed. We can say here is a fixed end. Here is a fixed end. Fixed end. So if the wave comes, like fixed end is just like a higher refractive index. Fixed end is just like higher. It meets a higher refractive index or a hard surface. It's a hard surface. You see, it means a hard surface, a fixed end. So it's like the wave comes and meets the glass. From air go to glass, it meets a higher refractive index, hard surface. It's like the rope is being fixed to the wall. So when the rope comes, yeah, it meets a fixed end. What happened? It cannot vibrate at the fixed end, and it will just go to the other side. You see these videos, yeah? See these videos, okay? I see here. This is a fixed end. Okay, I want you to see the whole videos. I want you to see this one. Yeah, only this one. I want you to see this one. Okay, display only. This one. Look carefully. See here. See, this is the fixed end. Yeah. You see here, this is the fixed end. Yeah, it's being fixed. This rope is being fixed at this point. It's being fixed at this point, so it cannot vibrate. Yeah, the string cannot vibrate at this point. So what happens? See what happened? You see, fixed end is being fixed to this pipe. I cannot vibrate at all. You see, invert. You see the wave invert to the other side. You see or not? This is called pi radian phase change. Pi radian phase change. You see again? It's being fixed. Do you see that? So you see, when the wave goes to this side, yeah, wave is actually going this way, but because it is fixed end, so the wave want to vibrate to the right hand side. But because this end is fixed, it cannot vibrate. So it have to being lashed to the other side. It will vibrate to the other side. Because it want to vibrate to the right hand side, cannot. So in the end, it result in vibrate to the left hand side. It's just like you punch on the wall and you feel painful on your fist. You feel painful on your fist. The wall has nothing. It's changed nothing. So this one is like you vibrate. You invert to the other side. This is what happened to the fixed end. Understand? This is what happened to the fixed end. Phase change happened. Invert. Initially it's going up, but it become going down. Okay, this fixed end. So now what happened if it's a loose end? Now what happened if you are using a loose end? A loose end, that means you just use a ring. You see, it's not fixed. Maybe you just use a ring, and then it means this one. The fixed end, the end cannot vibrate at all. This end cannot vibrate at all. But the loose end means this ring can vibrate up and down. It can vibrate. It's not fixed because the string is not fixed to the pole. Yeah, using a pole and a ring. Because it's not fixed, so this string can freely vibrate up and down. So if you're using a loose end rope, the wave comes. The reflected wave never change. No phase change happen. You see what happened here. Yeah, see these videos. If you are using a loose end, understand? If you're using a loose end, you see that. Okay, you see this one is not fixed. This one is a loose end. Why I say this is a loose end? Because now this previous one, the string is fixed to the pipe, but now this end is loose. Is connected with a smaller string. This smaller string, that means this end can freely move. Can freely vibrate. You see, it's not fixed to the other end. It's loose. That means this end can freely move left and right. See what happened? It's a loose end. Okay. It's not fixed to the pipe. Do you see that? You see the wave reflected. not inverted. No phase change happen. Initially it's going to the right. It's going to the right. But when it reflected, it's still going to the right. This is no phase change because this end can freely vibrate left and right. Okay, so that's why no phase change happen when reflected light. But you see, when it reached the end, the hand, what happened? You see, it invert to the other side. The place is holding the string. Yeah. What I can say is this one. The place it is holding, is fixed. You understand? It's fixed. That means the place is holding is fixed. The string is fixed. It cannot vibrate at the hand there. That's why for the hand there, it will have phase change. But at the loose end, there's no phase change. See what happened again. Yeah, see what happened again. Yeah, look at this one. See? Do you see that? At the end here, no phase change. But at the hand there is a phase change. See again? Phase change. No, sorry, again. This is the loose end. No phase change. Phase change. No phase change. Phase change. See? Again. No phase change. Phase change. See? See? No phase change. Phase change. So at the loose end, there, get no phase change. But at the hand there, because it is fixed to the hand, so got phase change. Okay. Okay. So that's the thing for the phase change. Now I want you to look back at these notes. Right. Let us close. Maybe we leave it open first. Okay. So what I can say is, if the end is fixed, so it cannot vibrate up and down. So the wave have to phase change, vibrate to the other side. Okay. But if it is a loose end, it can freely vibrate. So when reflected light, it will have no phase change, no phase change at all. It's just like the light travel from higher refractive index going to emits a soft surface. Soft surface, that means a lower refractive index. When the light meets a lower refractive index, no phase change at all. The light, yeah, it's like you meet a loose end. No phase change at all. Okay. So here we have two conditions. Okay. So I want you to look at this one. See this one? So we have two cases. We have two cases in thin films. One is travel from lower refractive index, lower refractive index going to higher refractive index. The second one is travel from higher refractive index going to lower refractive index. This one lower travel to higher refractive index. Okay. The one, okay, as I mentioned before, phase change only happen during reflection from lower to higher refractive index. So phase change only happen when? Only happen during this one. The light reflected from lower to higher refractive index. Travel from, let's say, air to glass. The reflection. This one got phase change. The rest no phase change. The rest no phase change at all. You see, no phase change for here, and for here. No phase change at all. No phase change. Okay. The transmitted light, no phase change. If the light go from higher refractive index go to lower refractive index, reflection, no phase change. This one also no phase change. It's just like this one. The first one is just like this one lah. Okay. You consider you have two ropes, a string, small diameter and a large diameter rope. Yeah, it's just like, you see, this is a small rope. It's like very easy to vibrate. You see, very easy to vibrate. But this one is like a very big rope. Big rope is like very hard to vibrate. It's like fixed end over here. we can say it's like a fixed end. It's like fixed end over here. Fixed end for this part. Yeah. So when the rope meets a big rope is this is the, we consider this is as a big rope. Big rope is like hard to vibrate, isn't it? The big rope is hard to vibrate. Okay, hard to vibrate. So hard to vibrate. So when the light reflected, where hard to vibrate is like fixed end over here. It's not fixed, but it's it meet the hard rope. Small rope meet the hard rope. Hard rope is like not tend to vibrate. Very hard to vibrate. It's like, so we can say it's like fixed end over here. So when the incident ray incident pulse meet this point, the reflected is got phase change. You see that? Got phase change lah, like this one lah. From lower refractive index, the light go from lower refractive index go to high refractive index. This part is hard to vibrate. That's why got phase change. And got phase change. The reflected ray got phase change. But the transmitted one no phase change. The transmitted one no phase change. Yeah. It's like the small rope meet the big rope. The big rope hard to vibrate. Yeah. So that's why this one will go to the other side, got phase change. Yeah, got phase change. The red one. So, but if let's say going from higher refractive index go to lower refractive index, it's like a big rope go to small rope. Like the video I show you just now. Big rope go to small rope. This one is just like small rope. We know is easy to vibrate, isn't it? Easy to vibrate. For small rope easy to vibrate. So we can say this one is almost like a loose end. It's like a loose end. So when the light comes, this part can easily vibrate. This part can easily vibrate. Yeah, this part just now that one cannot vibrate at all. This one can easily vibrate. So the reflected ray is no phase change because it can easily vibrate. Easy to vibrate. Yeah. So it's just like a loose end. So the reflected ray no phase change. The transmitted one also no phase change. It's just like this one. I did the video I showed you before. You see, if this one is connected to you see this one loose end. Loose end like a big rope. You see. Okay. I just show you the display only. You see, it's just like a big rope versus a small rope. Big rope versus small rope. You see, a big rope versus a small rope. The small rope is easy to vibrate lah, easy to vibrate. So this part easy to vibrate, left and right. So this one is considered like a loose end because it's like big rope meet a small rope. Yeah, so it's a loose end, easy to vibrate. So you see what happened? No phase change. You see that? Okay, hang. Yeah, hopefully no more hang. You see, no phase change. You see that? No phase change. Because you see the small rope easy to vibrate. You see that? Do you see the small rope? It so vibrate. It follow to vibrate, isn't it? Let me show you. You see? Too slow. You see that? Too slow. Yeah, it just, you can see the small rope vibrate to the other side. So I can say small rope easy to vibrate. Small rope easy to okay, go back to this one. So small rope easy to vibrate. Okay, so that's why the reflected ray no phase change. It's just like the glass meet the air. The glass meet the air. So this part is like a loose end. So the wave easy to vibrate. That's why here no phase change. Yeah. But this one, yeah, I can write like this lah. This is the like a fixed end. This is like a fixed end. Hard to vibrate. And this one is just like a loose end. A loose end. A fixed end hard to vibrate. That's why this one got phase change. And this one is loose end easy to vibrate. That's why no phase change. All right. So conclusion is phase change only happen during reflection from lower to higher refractive index. Phase change is pi radian phase change. That means the wave initially go up, it become going down. Yeah, like that lah. Okay, see you in the next videos.